Hello, we present GNN-AID, an open framework for analysis, interpretation, and defense in graph neural networks. It is built upon PyTorch-Geometric and provides a set of preloaded datasets. It also has an extendable API to add custom datasets, models, explainers, attacks, and defense methods. Also, it provides MLOps features to reproduce experiments. GNN-AID has a web interface in which you can visualize and analyze graphs, construct models, train them, add attacks and defenses, and visualize explanations. Here is our web interface. The first step is to choose a dataset. Let's pick a Cora citation graph from the PyTorch-Geometric package. Here the neighborhood of the zeros node loads. Let's increase depth and switch to another node. Accept default features. Here we see nodes colored according to classes and also can see feature vectors. On the right side, we can see some statistics like edges, degree, clustering, and so on, like degree distribution. Then we can construct a model. Let's add 2 Sage layers. After that, we go to Model Manager, where we can add some training parameters like optimizer, loss function, and train test ratio. Accept it. Then we can add some metrics and set number of epochs to train. Let's start training. On the right side, we can see model configuration and model architecture, where weights are changing during the training, and the training curve, where we see that accuracy is growing. Also, during training, we can see like embedding vector is changing, and also predictions are changing for each node. When the training is ended, we see that test accuracy reaches 86%. Now we switch to interpretation case. We choose a molecular dataset MUTAG, which consists of 188 graphs of 2 classes, mutagenic and non-mutagenic. Mutagenic graphs have many carbon rings, red nodes, and NO2 groups depicted as yellow for nitrogen and green for oxygen. We will build a model to classify them. It will consist of 3 gene layers and 2 linear layers. It will also has a special prototype layer which learns graph prototypes that explain the model classes. Model Manager has a set of specific parameters. We leave them as default and start model training. After several minutes, the model finished training by early stopping. Now we can get prototypes. For that, we choose the ProGNN explainer and run it. We see explanations as 3 prototypes for each class. By design, prototypes reflect the most influential parts of the dataset graphs for the model, and we can see that they highlight NO2 groups, which is consistent with knowledge from chemistry. A user can also run same cases from backend. We show an example with model attack and defense. Let's run it and explain the code. We again take Cora citation graph and train a model on it. In GNN-AID, we use universal configs to specify datasets, models, model managers, attacks methods, and so on. They accept arbitrary parameters as well as enclosed configs. In this example, we add FGSM attack and a gradient regularization defense. We train 3 models. The first one is without attacks and defenses. We measure accuracy and F1. Then we add FGSM attack and see how metrics drop down. For the third model, we add the defense and measure again. Classification quality becomes high again.